Hi, everybody, and welcome. My name is Dave Cabellis. I'm a product manager with the Enterprise Cloud Native Java group. With me is Mark Nelson, who's also with the same group. Today, we're here to talk to you about hybrid applications for the enterprise. We are going to be talking about a lot of forward-looking information here. This is our standard safe harbor statement. In general, it means I'll talk about plans, and plans may change from time to time. This is what we're going to be talking about today. First of all, we're going to talk about some background around challenges and needs for the enterprise around evolving traditional applications with microservices and new cloud-native applications. Then we're going to dive into some information about a new project, Verrazano, that we recently pushed to open source. We've got some great capabilities there. We'll also talk about Verrazano and hybrid applications in a day one technical scenario. And then because we're talking about enterprise applications, we really need to be thinking about day two and manageability, especially within the DevOps, GitOps, lift and shift scenarios. And at the end, we'll have some time for questions and answers. And I just do want to point out that we have a couple of experts on the line waiting behind the scenes. So if you want to type questions in the Q&A box at any time, please feel free to do that. We're happy to get as many questions as possible. We want you to get as much out of this session as possible also. So let's start with challenges. We've heard numerous times about container adoption and container orchestration adoption. And why is this happening? Really, it's everybody's looking for improvements around development times, development agility, deployment velocity, reliability, scalability, and really all of this, this adoption of DevOps enables customers to be able to react to changes in your business needs in a more responsive way. These trends, we see them with new applications, with cloud-native applications. But these trends also apply to existing applications, and this is where things start to get messy. Why is there a need to do this? It really has to do with trying to get those same benefits, the deployment velocity and the agility and reliability, as well as the benefits of managing within the same environment. And just about everybody says, I want these benefits without having to rewrite my application. I want to be able to pick it up and move it. I don't really want to, reinvest where I already have large investments. Beyond that, we also hear challenges around multi-cloud. Just about every enterprise has a multi-vendor strategy for just about everything, and cloud is no different here. And so there's a need for deploying some applications on cloud A, some applications on cloud B, and then of course there are some applications that would run on a private cloud on premises for the foreseeable future. So this means enterprises need to be able to manage those applications, manage the life cycle of those applications across these environments. And of course, I did mention day one and day two operations already. This needs to be part of the design. And Kubernetes alone is not enough to meet these needs, right? So we do see Kubernetes adoption as the de facto standard for orchestration of containers. But Kubernetes provides things like high availability and scalability within a cluster, but it doesn't really give you the rest of the manageability story. The Enterprise Cloud Native Java team at Oracle has been aware of these needs for some time, and over the past few years, we've been delivering solutions, features, new products in a cadence, right? In like a drumbeat of things that are really meant to help solve these problems. It started with Docker and Kubernetes certification of WebLogic server and Coherence. And then we added the WebLogic Kubernetes Toolkit, which includes the WebLogic Kubernetes operator. This toolkit is a series of tools that enables you to take an existing WebLogic domain and the applications running in it, containerize that, and then move it into a Kubernetes cluster where the WebLogic Kubernetes operator manages the application or the domain at runtime. Really makes all that really simple. And we didn't stop there. We added a similar operator for Coherence. If you're not familiar with Coherence, Coherence is an in-memory data grid It actually goes, significantly beyond just a distributed cache. It enables you to run, really to execute application logic across the cluster of cache members. So pretty cool stuff there. Really solves as a great state management platform for microservices as well as traditional applications. It's been used with WebLogic for many, many years. And then recently we announced the Coherence Community Edition, which is, we pushed Coherence to open source. And so now that, great state management platform is available to, an increased number of developers. Really, it's ubiquitously available. And then we released Helidon, I think about 2 years ago now. Helidon is a set of Java libraries that is targeted at the millions of Java developers out there who have been writing enterprise applications for years. And now, how do we help customers leverage those skills and then move them into the new cloud-native microservice world? And that's where Helidon comes in. Helidon, there are two flavors for Helidon. There's the SE flavor and the NP flavor. SE is a tiny footprint micro framework for running applications, and then the NP version is an implementation of the Jakarta EE micro profile. And then Oracle has developed and delivered Grovium. Grovium is a multi-language virtual machine for maximizing performance, minimizing startup time, minimizing footprint. This is great for microservices. It's also great for traditional applications. WebLogic is certified to run in Grovium, and we've seen some nice performance boost there. So all of this is, a series of things that our team has been delivering over the past few years. And this is where, Verrazano is the next step in the evolution of this series of things. And so Verrazano is an enterprise container platform that provides workload management across environments. So think multi-cloud we've been talking about. It provides integrated pre-wired observability. So when you deploy applications into Verrazano, it automatically captures metrics, logs, distributed trace information, and pushes that to a central location where it's made available in predefined dashboards and so forth. Application lifecycle management is also really important here, especially when we're thinking about multi-cloud, right? So when I think about series or groups of traditional applications and microservices managed together, and now I'm going to spread them across an environment or multiple environments, and now I need to manage the lifecycle of those applications. It's really important that we get this right, and this is where Verrazano does a lot of the heavy lifting for you, right? It makes sure, when you do an update to one component of your application, it makes sure that that's the piece that gets updated and minimizes any other disruption. Security is also baked in, right? It has to be with anything we're talking about for an enterprise container platform. This includes protecting Verrazano components as well as the applications that run within the Verrazano environment. And then multi-cluster infrastructure management. So Kubernetes itself sometimes falls into a gray area. Is it part of the application layer? Is it part of infrastructure layer? We view it as, if you're running applications across these multiple clusters, you need to have visibility, you need to have some level of control of what's happening at the Kubernetes layer. So we build that into Verrazano as well. So this is capabilities of the Verrazano Enterprise Container Platform. And it is built from open source components. Many of these, you probably already know, use, and love. So besides the things we see on screen here, we augment this set of open source components with a series of operators and admission controllers. It's the code that makes all this stuff really easy to work with, easy to manage the platform itself, easy to manage your applications that you're deploying onto this platform. And it is a curated stack. Right, so Oracle takes the open source component, scans it for vulnerabilities, builds it from source, and then makes the container available for use with Verrazano, so that when you're using this, you have confidence. You know that there are no known vulnerabilities within these various components. This platform is designed to run traditional applications like WebLogic and Coherence workloads. We've got some special capabilities that make that work really well. And of course, we do leverage that cadence of deliverables I talked about earlier, including things like the WebLogic Kubernetes operator. So this is, let me move my traditional applications into a DevOps environment. And then Verrazano is also built to run your Java microservices. I talked about Helidon already, talked about Grovium, talked about Coherence Community Edition. So as I'm building new Java microservices, I would want to deploy them and run them and manage them within the same enterprise container platform. And then, any platform like this really needs to be able to run other services as well. It can't just be Java. It's got to enable you to run whatever you want to run here. And so this is meant to run, other microservices like Python, like Node.js. And all of this, again, is designed to run across multiple Kubernetes clusters, across cloud environments, and it is all pushed to open source. At the bottom of the screen is the URL for our GitHub repository. So let's get into a little bit how Verrazano actually works. So multi-cloud, again, is part of the design. And in order to support that design, Verrazano has concepts of a Verrazano management cluster and managed clusters. So the way this works is you install Verrazano into the management cluster. This is a Kubernetes cluster. You install Verrazano operator, rancher, Istio control plane pieces, Keycloak for security, the Elastic stack, the Prometheus stack. And then you create or import additional clusters that get added to the Verrazano environment. And when you do that, Verrazano pushes some components to those managed clusters. Many of those components are actually pushed sort of on demand, but some are pushed in advance to make things run smoothly. So then, these clusters become part of the Verrazano environment. And then Verrazano also sets up a distributed Istio service mesh. The service mesh is important for things like service discovery, traffic management, routing, mutual TLS across components that talk to each other within the mesh. That's part of the security story, as is network access policies. This service mesh is locked down by default, so that everything is protected. And we automatically set up network policies for things that you deploy into the service mesh, so that those things can talk to each other and nothing else can. The service mesh also enables us to set up an ingress, so that we can route traffic into the mesh and then within the mesh wherever it needs to go. And the mesh also gives us distributed tracing. So as requests go from Envoy sidecar to Envoy sidecar, we're able to capture that tracing information and surface that to you. And then thinking about application lifecycle management. So again, this is going to be spread across these multiple environments, and I need to be able to manage multiple applications as a unit. So Verrazano has concept of an application model and an application binding. The application model enables you to list the application components that you want to run. So in the example I'm showing on the screen here, I have 2 WebLogic domains, I have a Coherence cluster, I have 3 microservices, and all these are, it's a group of applications that I want to manage the life cycle together. I want to be able to deploy them somewhat as a unit into this environment. And then the model also lets me provide some other information specifically around connections that these components would need. Connections between those components in the model, connections to services running in the various cloud environments, connections to databases, connections to REST endpoints, things that I need to do outside of the application itself. And then the application binding enables you to take that model and map it to an environment. So it includes things like placements. For example, I want to place application 1 on cluster A in a specific namespace. And then I need connections to a particular database. I think if I'm moving from dev to production, I want to now talk to the production database. So that needs to be externalized and put into the binding. Ingress details for the application as I'm running it in this new environment, connections to other endpoints like messaging endpoints and so forth. So, lots of good capabilities there. As you deploy this model and binding into the Verrazano environment, Verrazano does the magic, right? It does the heavy lifting, does all the wiring we talked about, spreads it across wherever you want it to spread, and then also spins up a dedicated monitoring stack. When we look at an environment like this, we think of, a set of engineers, an SRE team that would be managing an application system like this, and they need access to the monitoring data, the observability data for this system. And so by putting it into a dedicated monitoring stack, we have segregation, right? And so those engineers have access to that data, and it's not commingled with other data. Pretty cool stuff. Mark, I'm hoping you can kind of take us into a little bit deeper dive here.
Sure, Dave. So when you go to deploy your application into a Verrazano environment, you would use the standard Kubernetes tools like kubectl, for example. The first thing that you would do is to apply your model file to the environment. So as Dave said, your model file describes the components of your application and how they're connected to each other. This is a standard Kubernetes YAML file. The first thing that will happen is that we'll go to the admission controller, which will check to make sure that the syntax is correct, that if it refers to anything that should be pre-existing, like a database secret, for example, that does actually exist. And then if everything is okay, it will create a Verrazano model custom resource, which is represented by this little blue box here. So nothing else happens at this point. Remember, the model is just describing the common components of the application. So next, we would apply our binding file. So again, this is a standard Kubernetes YAML file, and this describes the environment or instance-specific aspects of the application for this deployment. So as Dave said, this is where you would put in the connection details for the database, or the DNS names that you're going to use to surface web UIs and that sort of thing. Again, this goes to the admission controller, which checks that it is valid, that the model it refers to exists. If there are any other resources that should exist, it'll check that those are there. And then it creates the Verrazano binding custom resource, which is represented by this blue VB box. And this points back to the model. So at this point, the Verrazano operator is going to take a look at the combination of the model and the binding file and work out what needs to be done across all of the managed clusters to deploy this application. So firstly, it would go and create namespaces, whatever namespaces are required in each of the managed clusters. If there are things like secrets or config maps that need to be copied into those namespaces, for example, with database connection details or administrative user details for a WebLogic domain, then it will go and create all those secrets in the right places. Next, we deploy some micro operators that are a part of Verrazano that then control the deployment of different types of applications. So on this example, we have our WebLogic, Helidon, and Coherence micro operators. The Verrazano operator will create a custom resource to talk to each different kind of micro operator. So in this example, it's creating a custom resource that describes a WebLogic domain. The micro operator will then deploy the WebLogic Kubernetes operator out of the WebLogic Toolkit that we mentioned earlier, and create a domain custom resource. In response to that, the operator will run the introspector to look at the domain. It will start up the admin server and then manage servers. And we also do things like injecting configuration using the WebLogic configuration override capability. So for example, we would update the data source in the WebLogic domain to have the correct connection details and credentials based on the Verrazano binding. Similarly, the operator will create custom resources that tell the Helidon micro operator and the Coherence operator what to do. So as you can see here, the Helidon operator would deploy some microservices. The Coherence operator is responsible for creating in-memory data grids. Verrazano will also set up the network security, as Dave mentioned. So it will configure the network within the service mesh so that only those components that were explicitly declared to talk to each other are able to do so, and all other traffic is blocked. So creating a secure by default network layout. We create the ingresses to access any exposed endpoints. The ingresses include details like the DNS names to respond to, the routing rules for different paths, certificates, and so on. And we also stand up the application telemetry stack and automatically wire up all of the components so that logs and metrics are flowing through to the telemetry stack. So we do this, for example, by injecting a FluentD sidecar to send logs to Elasticsearch, or by configuring Prometheus to collect metrics from various pods.
Let's take a look at a running Verrazano system. This is the main Verrazano console user interface. In this environment, we have two models and bindings, Hello World and Bob's Books. From here, we also have easy access to the system telemetry and other user interfaces. Let's drill into one of the models. You can see this model is used by one binding. It has a number of components, including a number of WebLogic domains, some microservices, and some Coherence clusters. A number of connections are defined between the components. We have various ingresses to access the user interfaces, and we have some secrets. Let's go back and look at the binding. You can see here that all of the components are in the running state. We have easy access to the application telemetry. Here's one of the application's endpoints called Robert's Books, and another called Bobby's Books. We can use this application, and now let's take a look at the log messages that are coming from this application. Here's the raw WebLogic log data in Kibana. We can use this to filter and search and narrow in on the particular information that we're interested in. For example, we might want to group by the server name and look at the message and severity. And maybe we're only interested in the admin server. We also have the same kind of logging data for Coherence, Helidon, and other types of components, as well as the operators that we install in the system. We also have Grafana dashboards for WebLogic, Coherence, Helidon, and so on. This is a WebLogic dashboard. Let me just refresh here. You can see information about the heap, some garbage collection going on there, CPU. Here's information about the web application, including the number of sessions, error rates, request rates. This application doesn't have any data sources or JMS, but if it did, we also have the ability to see information about those. So that's been a quick tour of a running Verrazano system.
So let's talk about how Verrazano fits in with DevOps and CI/CD practices. On this slide, you can see our original application model and binding that we discussed earlier with multiple WebLogic domains, Coherence cluster, multiple microservices. Let's assume that we find a bug in one of the WebLogic applications and we need to make a code change. So we update, for example, our Java web application, we rebuild the WAR file, and in our CI/CD pipeline, we would rerun our test suite to confirm the behavior of the application. And if that's all good, we would go and create a new or update the Docker image for that domain. So imagine that WebLogic 1 was the original version, and WebLogic 1.1 is our new updated image. Now, we can create a new Verrazano model file, which we're calling app_model2 here, which is basically the same as the first one. The only difference is we're now referring to this new WebLogic 1.1 image. Now, remember, when we apply the model, nothing else changes in the environment. It's the binding file that controls when deployments take place. So if we're happy with our change, we can update the binding file or have our pipeline automatically update the binding file to point to app_model2. When we do this, Verrazano is going to look at the existing environment and compare that to the model and binding file. And in this case, it'll work out the only difference is that WebLogic domain needs to be updated. So it will update the custom resource that tells the WebLogic operator to go and do a rolling restart on that domain, pick up the new version of the application. The operator will make sure that it maintains a minimum availability while it's rolling the domain. And after a short period, the whole domain will have been restarted on the new version of the application. None of the other components will be touched because they have not changed. Another interesting scenario to look at is moving a existing on-premise WebLogic domain or Java EE applications into a Verrazano environment. As Dave mentioned, the WebLogic Kubernetes Toolkit that we have been working on and had in open source for a couple of years now, but still fully supported for WebLogic customers, includes tools like the WebLogic deployment tool, which will allow you to introspect an on-premise domain and turn that domain into a YAML file, a model that describes the domain, and also collect the resources that are needed to recreate that domain. Things like your Java application archives, your deployment plans, and so on. And it can also create a Verrazano model and binding file to describe that WebLogic domain. We have a tool called the WebLogic image tool that can create the Docker image to run that domain for you. It can update a previously existing image if there is one, or it can create a new one from scratch. It manages the layers to make sure the image is as small as possible and performs as well as possible. It can automate the processes like obtaining patches, checking for conflicts. It can even change the version of WebLogic. So if you wanted to introspect a 12.2.1.2 domain and run it on 12.2.1.4, it can make that change for you on the way through. You can then either go ahead and deploy the model and binding files into Verrazano, or perhaps you copy the content into a larger model and binding file that describe a larger application that this domain is a part of.
So pretty cool stuff. Thanks, Mark. And so we've talked about this enterprise container platform. This, what we have available today is source code on GitHub at the URL showing here on the screen. We also published our Docker images on the Oracle Container Registry. We have installation scripts for Oracle Cloud and Oracle Cloud Native Environment. We have 4 examples that are out on GitHub. We have the Bob's Books example that Mark showed some of that earlier today. We have a Hello World example. We have the Sock Shop example from Weaveworks on GitHub. And then we also have a lift and shift example that shows how to use the WebLogic deployment tooling, the WebLogic Kubernetes Toolkit to do a lift and shift of an existing WebLogic workload into Verrazano. So pretty cool stuff. I mean, I hope you find this interesting. We'd also love to have you reach out to us. So we have a Slack channel with there's a URL here that you can go to and join our Slack channel. We have an email account. I've been tweeting a little bit, so follow us on Twitter, please. Source code, like I said, is there. We have a documentation site, verrazano.io/docs, and our homepage is there as well. So that's our spiel for today. Let's see if there are any questions. So it looks like here's one. Mark, I'm going to pass this to you. It says, can you clarify how Verrazano relates to the WebLogic operator? You mentioned a toolkit too.
Sure, thanks for the question. So the WebLogic Kubernetes Toolkit is what we call a collection of tools that we spoke about. So the WebLogic Kubernetes operator is the main one. It allows you to run WebLogic domains in Kubernetes. It helps with things like scalability, with automating the creation of services and configuring load balancers and ingresses and all those kinds of things that you need to do to run an application in Kubernetes. The deployment tool that I mentioned, which allows you to introspect domains and create domains, update domains, is part of the toolkit. The image tool that we talked about is another part of the toolkit. And we also have a logging exporter that will allow you to export WebLogic logs into Elasticsearch using a push mechanism. And we have the metrics exporter, which is what we use to get the WebLogic and Java metrics out of a WebLogic domain into Prometheus. So Verrazano builds on top of all of these tools. We're reusing the exact same tools that you could go and get from our open source offerings there, and building a layer on top of them, a little automation and a little bit of glue and magic, as Dave said, to make them work together in the optimum way.
Cool, thanks, Mark. Another one I'm going to pass to you, and it's going to be pretty related to what you were just talking about with metrics and so forth. The question is, how can I diagnose performance problems with my applications when they're running on Verrazano? Yeah,
there's a number of capabilities included. So obviously you can go and look at the logs in Kibana, and you can search for particular things, like you might set up rules that look for out of memory conditions or that sort of thing, for example. You can use the metrics that are extracted from the WebLogic domains. And the dashboards that you saw are provided out of the box. And again, they're open source, so you can take those and customize them to your heart's content. And obviously they can be used for looking at things like, error rates or response times, or analyzing the performance of the garbage collector and all that kind of stuff. You also have some other capabilities. So within the Istio service mesh, you can use tools like Kiali to look at the traffic flowing through the mesh in real time, which can help you to get an understanding of whether there are any bottlenecks in the network, internal network within the mesh. And we also have distributed tracing capabilities using tools like Jaeger and Zipkin, open tracing. So there's a certain amount of information you can get to see packets moving through the service mesh, going from different components, in and out of WebLogic domains, microservices, even out to databases running outside the cluster, and so on. So you can see how much time is spent in each of the components and identify issues and drill down, and so on. So yeah, lots of capabilities there for analyzing performance of applications. Maybe this one can be for you, Dave. I see someone is asking, how does Grovium fit in with Verrazano?
Absolutely. So Grovium, as I mentioned earlier, it's a a multi-language VM that's meant to optimize performance. So this works well. So if we're starting to think about running microservices and traditional applications together, having things like startup time and performance optimizations like memory footprint really starts to come into play. We've certified WebLogic on top of Graal. So if you want to run WebLogic in this optimized form, you can. And then Helidon itself, which we efficiently manage Helidon applications. Helidon works really well on top of Grovium. In fact, you can create a native image of a Helidon application on top of Grovium, which means really tiny footprint, really fast startup times. So Grovium is part of the quiver of solutions. So Verrazano kind of sits on top of a lot of the things like we talked about the WebLogic Kubernetes Toolkit. And then beyond that, it's like all these things kind of come together to provide like an optimal place to run microservices and and your traditional applications. I'll take this one again too. I'll take this next one too. I see does Verrazano support GitOps? So Verrazano by its nature is meant to be super friendly for GitOps and DevOps, right? So GitOps, I think of, okay, I'm gonna store my configuration as code in YAML files, right? And Verrazano fits right into that world, right? You put your application model, your application binding into YAML files. When you check in code, it can do all the processing that needs to happen to update your application and then push to Verrazano, right? So all of that becomes automated as well as auditable, right? So everything is done, typically in a GitOps scenario, you turn off the ability to manually, deploy. It has to go through the GitOps system. And this way, everything is logged, everything is auditable and automated, of course. Mark, you want to take this next one? What if I have?
Yeah, I assume. Okay. Yeah. What if I have my own logging and monitoring infrastructure? Is the question.
Yep.
I think we're almost out of time, so let me be quick on this one.
Yep.
So the approach with Verrazano is we'll do a lot of things for you and try and do a sensible, good job, like provide you with common tools like Elasticsearch and Prometheus and so on. But you're not locked in. So if you happen to have your own tools that you prefer to use, then we give you the ability to opt out of that and instead configure the endpoints or whatever you need to send information to your own telemetry stacks.
Cool. Okay. Well, I think that's all I'm seeing for now. If we look at who's up next, please hang around for who's up next. You'll actually have to log into a different Zoom. Up next is ZGC, the next generation low latency garbage collector with Per Helidon, or keeping your Java application secure, cryptographic improvements and best practices with Sean Mullen and Chris Rise. You can go to the website here for the agenda at developer.oracle.com/devlivejava. And then for each of the sessions, there's a button to click. You can click that button and join the upcoming sessions. So thank you so much.